Good morning friends. Today I will discuss about some few points about the beam. What is single reinforced beam? First of all, if the steel reinforcement is provided in tensile zone only, it is called a single reinforced beam. But if the steel reinforcement are provided in tensile as well as the compressive zone, it is known as the double reinforced beam. Next I will discuss about the balanced section, under reinforced and the over reinforced section. In case of a balanced section, the area of the steel reinforcement is such that the steel and the concrete fails simultaneously. So please remember the definition of a balanced section of a beam, that if area of steel reinforcement is such that it is the steel and the concrete both fails simultaneously, it is a balanced section. What is under reinforced section? The area of the steel is provided in such a way that it is less than the area of the steel of a balanced section, then the steel will fail before concrete. It is very easy to remember or understand. If you provide less steel than whatever is needed for a balanced section, then what happens? As you are providing the steel reinforcement less, the steel will fail before concrete. So it is called a under reinforced section. The third one is the over reinforced section. It is just the opposite of under reinforced. That means if the area of the steel provided is more than the area of the steel needed for a balanced section, then what will happen? The concrete will fail fast before steel. So that is called the over reinforced section of a beam. Now let us discuss one point over here, that all practical sections are under reinforced. Why it is not a, actually ideally it should be a balanced section, but all the practical sections are under reinforced. It is not over reinforced, it is kept under reinforced. Why? The answer lies over here, that as steel is a ductile material, so if you see or if you remember the stress strain curve of a ductile material, you remember that the ductile material gives signal before failing. That means what? It forms a neck, and by neck formation it gives signal that it is going to fail after some time. So it is always preferred that a ductile material, if the steel being a ductile material, if it fails before concrete, it will give signal. So it will be helpful for us to take precautions. Whereas concrete being a brittle material doesn't give any signal before failing. It just breaks or fails. So all the practical sections are designed as under reinforced section. Next, this is the diagram for a balanced under reinforced and the over reinforced section. Please remember or keep this diagram in your mind, in your brain, like anyway, because this is the very important diagram. You will be given one question and you have to identify that which diagram, which section diagram it is. Let us start, and you will understand what I am telling over here, explaining over here. This is the rectangular section of B and D, and you can see the steel reinforcement over here. The first diagram shows the balanced section, correct? Now the blue line shows the neutral axis. In case of a balanced section, the critical NA and the actual NA, they coincides, correct? The second one, that is the under reinforced section. The blue line is what? Critical NA, but actual NA in case of under reinforced section, you can see with the red line, it is above. And in the third case, that is the over reinforced section, that the critical NA lies above the actual NA, or the actual NA neutral axis lies below the critical NA. So please remember this diagram. You have to identify that for which this is the stress diagram. So which section diagram you have been given, and you have to identify it. Okay. Now depth of a balanced section, please remember this table also, that in case of a mild steel Fe 250, that is the depth of a balanced section is 0.53 D. D is, as you can see, the effective depth, that is from the center of the reinforcement till the farthest fiber, correct? In case of a Fe 415, Fe 415 it is 0.48 D, and in case of Fe 550 it is 0.46 into D.